Talk about the Aldol chemistry and Aldol reaction. Okay, and the idea is, well, remember initially when we just had a regular ketone such as acetone, and we add LDA, we get deprotonation. Okay, we generate a negative charge on the alpha carbon. Okay, we just add that to an SN2 target, and we simply just get this molecule. Okay, now with Aldol chemistry, it's a little bit different. Okay, so and the important thing about this is that everything was 1 mole, so we added 1 mole of each thing. Now with aldol chemistry, what if I take this aldehyde here, and in solution I add 95 mole percent, so 95 mole percent, and I add a strong base such as sodium ethoxide of 5%, 5 mole percent. Okay, how this works is that I'm going to generate the original molecule, which is this, plus I'm going to generate the one that's deprotonated. Okay, so notice my alpha carbon is this carbon here, and I deprotonate. Okay, so this is a general form, and once this happens, now I generate a negative charge that will go ahead and attack my carbon and displaces it. And so I have a negative charge now. Yes, so if I want to run this reaction forward, I now have a carbon that has a negative charge. I have an oxygen that has a negative charge. Here's my hydrogen. Okay, and this carbon is bonded to this carbon that has the hydrogen there. Okay, now in the second step, so we typically add this in base first in the second step, and then we use ethanol. Okay, so in the second step, this is actually going to grab the hydrogen off ethanol and give us back ethoxide in solution. And so we come to a structure that looks like this. We have our alcohol, still have the aldehyde, and we have that. Yeah, and this is called a beta hydroxy carbonyl. Okay, so the idea is that we're forming an alcohol and some sort of aldehyde or carbonyl together. Okay, we're forming an aldehyde and a carbonyl together. Okay, and in fact, this reaction will go. Some professors will take it here that this is the product of the reaction. Okay, but if we actually lose water, we'll actually get the alkene. So if we lose water, we'll get the product to be something like this. We'll get the unsaturated compound. Yeah, so either or is correct. Some professors just want you to go the extra step, and while some actually in solution will just stay like this. So that's the general form. Okay, so let's look at another example. So what if I took acetophenone? Yeah, if I took acetophenone and add 5 mole percent, add 5 mole percent of sodium ethoxide. Yeah, remember we said that 5 mole percent of the base, we're going to generate the original molecule. So we're going to generate the one that's deprotonated. There's my alpha carbon. Okay, so I will generate deprotonate one of those hydrogens. Okay, and also get the original molecule back in solution because it's 95%. Okay, so now we come to this reaction. Well, this is just going to set the carbonyl, and we get a negative charge on the oxygen. So if that is true, then we shall come to a structure that looks like this. Yeah, I have my ketone, I have my carbon. This carbon is now bonded to a carbon that now has a negative charge on the oxygen. I still have this R group here, and then I have this benzene group here. Yeah. Now what happens at the end? Ethanol, this will take a hydrogen from ethanol, okay, and form ethoxide back in solution. And so we come to the alpha beta. We come to the beta hydroxycarbonyl. So we get this. So we get our ketone that now has an alcohol. There's my CH3 group here that represents this. And then we have the phenyl group here. So you could see the pattern. We're creating alcohols adjacent to the carbonyl. Okay. And again, if we lose water, okay, we actually create the alkene. So here's my ketone. Yeah, and my alkene will be right here. So either these products is correct. Now, some of you might wondering, how does the alkene come about? Okay, how does the alkene come about? Well, remember, we still have two hydrogens here. We still have two alpha hydrogens, because remember we started with 3 initially. Yeah, so we started with 3 initially. Okay, and so when we deprotonate, we still had two. And so actually sodium ethoxide, let me kind of squeeze it in here. The base will actually come in again, and it will actually deprotonate. Okay, it will actually so it will actually deprotonate and form the double bond and expel hydroxide. Okay, and so this is how we get the alkene. But usually they don't want the reaction mechanism for that is not required. They just want, usually you'll just see minus H2O, which means that you're losing water to go to the alkene. Okay, so you could definitely see the pattern. So what if we take acetone and add 5 more % again, okay, and sodium ethoxide. And again, your book might use as a different base. Any strong non-nucleophilic base will work. Okay, remember 5 more % of the base, we're going to generate the deprotonated form of the molecule plus the original. Okay, now this will become nucleophilic, it will attack, and we'll get a negative charge on that oxygen. And so if I'm looking at this, we'll get to a structure that looks like this. This carbon now is bonded to a carbon that has a negative charge. There's one of my R groups, and there's my other R group. Okay. Now, if that is true, then the second step, ethanol will come in. We'll take those hydrogens off, and we form ethoxide back in solution. And so we get the alcohol there. And this is the product that we'll get. Okay. This is the product that we'll get. Now, if we want to unsaturate it, again, if we want to lose water, okay, the product will look something like this. Yeah, so I'll have the alkene. So this is the alpha beta unsaturated carbonyl. Again, and these two they're pretty much the products. Now your professor again might prefer another over another, but again these reactions will actually go, and so again it's nothing hard. You could definitely see the pattern here. Yeah, and it's very similar. It's very similar. If I don't even have to add 5 more %. If I take this molecule here, and if I change the percentage now to just being 1:1, so I could take this compound plus let's see, I could take 2 acetophenone. Yeah, I could take 2 acetophenone. Actually, that's not 2 acetophenone. I could take benzaldehyde and acetophenone. Okay, so if I take benzaldehyde and acetophenone and I add sodium ethoxide in the first step, yeah, what would happen? Well, remember, we always look for alpha carbon deprotonation. Okay, so where's my alpha carbon? Well, it can't be on benzaldehyde. Benzaldehyde has no alpha carbons. There's no hydrogens here, and this hydrogen is the carbon has to be alpha. There has to be a carbon that contains the alpha hydrogen. So the only alpha hydrogens are here. And so if we throw these molecules in solution, I will get the deprotonation of one of those hydrogens off acetophenone, and then I still have benzaldehyde that will now be my electrophile. The carbonyl will be my electrophile. This will attack in this place. Okay, So we get a negative charge on that oxygen. Okay, so we get a negative charge on that oxygen. So we still have this is now bonded to a carbon that has a negative charge on the oxygen. There's our hydrogen. Okay, and then we have this whole R group here, this phenyl group here. Again, and this just picks up a proton from ethanol. Yeah, picks up a proton from ethanol. Yes, it should be going to the hydrogen. It picks up a proton from ethanol and generate ethoxide back in solution. And so we come to a structure that looks like this. There's our alcohol. There's our phenyl group. Yeah, and remember we said we have two hydrogens, two alpha acidic hydrogens here. So again, what does acid do? They react with base. So if we have ethoxide again in solution, it will actually come in and deprotonate, form the alkene, and displaces hydroxide. And so with that being the case, these products are equal. So we form the alpha beta unsaturated carbonyl. Again, either or is okay. It all depends on what your professor wants. Now, if on a test they just ask you to predict the product, I would just go the furthest and simplify to the alpha beta unsaturated carbonyl. Yeah, I'll simplify to the alpha beta unsaturated carbonyl. But either or is fine. Okay. Now, what if you take this molecule here? Yeah, and you added a strong base such as sodium ethoxide. Okay, what would you get? Well, in this case, the molecule is symmetrical, and we have alpha hydrogens on both sides. And alpha carbon on both sides. So there's alpha carbon 1, there's alpha carbon 2. So it doesn't matter which one you deprotonate in this sense, okay? So we're going to generate, a negative charge on one of those alpha carbons, okay? And then literally this is going to ring close. So this will actually attack its own self and create the oxygen that's negatively charged. So let's count hydrogens. Let's count how many stuff is gonna ring close. So we have 1, 2, 3, 4, 5, 6. So we know we're gonna form a 6-membered ring. Okay. So if I'm looking at this, I'm gonna form a 6-membered ring. Okay. So let's see. I have my ketone here. Yeah, I have my ketone here. Okay. So this is carbon. So let's call this carbon 1, 2, 3, 4, 5. Okay. Yeah, so that's 5. Here's 6. Here's carbon 6. Well, what do we have on carbon 6? Notice I have a methyl group here. Yeah, so on carbon 6 I have a methyl group. Okay. And I have an O minus. Okay, I have an O minus. So let's look if this makes sense. So let's see. This is carbon 1, 2, 3, 4, 5, 6. Carbon 1 is bonded to 6. We have a methyl group on carbon 6, and we have an O minus. We generate an O minus on carbon 6. Well, again, in the second step, ethoxide now is going to come in. Ethanol is going to come in and it's going to seat the hydrogen and form ethoxide back in solution. And so in this case, we generate something that looks like this. We have the alcohol, and then again, if we just lose water with another base deprotonation, we'll actually get the alpha beta unsaturated carbonyl, and so we get the alkene. Okay, but again, these are equivalent. It all depends on what your teacher wants. And actually, in research, I'm actually doing these types of chemistry, and we'll actually get the NMR to give us the broad alcohol peak there. And sometimes the reaction does not go full for it to give you the alkene. So that's why I said it all depends on what your teacher wants. Okay, so that's how we make these types of compounds. Yeah. So I want to take a look at one more last one when we talk about the synthesis of these compounds. Yeah. So if I take this compound here, if I take this compound here and I add sodium methoxide. Yeah, if I had sodium methoxide, yeah, well, I'm gonna get deprotonation. The idea is now, where is my alpha carbon? Well, it's always adjacent to my carbonyl, and you could see that the only alpha carbon that we have here is this carbon here. Yeah, the terminal carbon. And so when we add the base, we're gonna get deprotonation. So we have generated a negative charge on that. Okay, and we redraw the rest of the molecule. Now we can definitely see that this will react with itself. And the rule in organic chemistry we always say is that whenever we could form a 5, 6, or 7-membered ring, we're going to do it. Simply because energy likes low stability, and these reactions actually ring close. Okay, so if I'm looking at this, let's count how many stuff is going to be in a ring. So we have 1, 2, 3, 4, 5. So you can see that we're going to form a 5-membered ring here. Okay, so this will attack the carbonyl and actually form a negative charge there. Okay, so if that is true, then we come to a structure that looks like this. Okay, here is carbon 1. Here's the carbonyl, carbon 2. Okay, so we have something that looks like this. Okay. We have an O minus. Okay, and the idea is that you could come up with these structures real quick if you label your carbons meticulously. And so let's see if this makes sense. This is carbon 1. This is carbon 2 that has our ketone. This is 3, which is right here. This is 4, which has these 2 methyl groups here. And this is 5 that has the hydrogen. Remember, there's one hydrogen, which is here, and also have this negatively charged oxygen, which we just formed. Okay, and so if we treat this with ethanol now, this will actually seek the hydrogen and reform methoxide in solution. Okay, and so if I'm looking at this, I'll get my alcohol. Yeah, and again, we said that we could lose water. It doesn't matter. This product is actually equally as acceptable as the alcohol compound. Yeah. So here's the process. So there's a process of whether we use 5 mole% with the same molecule, those will react with itself. And then again, we could totally ring close. We could use different molecules. So that's the idea behind aldol chemistry. We're using ketones and aldehydes to actually form alpha beta unsaturated carbonyl or alpha beta hydroxy carbonyls.